Hello everybody, my name is Jonas Bengtsson. I'm the CEO of the Australian consultancy firm called Edge Environment, and I'm here to talk about lifecycle thinking and infrastructure today. So why do we want to talk about sustainability and infrastructure in the same sentence? Well, what we're facing in the world is a growing population. We've got over 7 billion people in the world, and we're going towards 10 billion by mid-century. And we're consuming more and more. We get wealthier, and we per capita growing in affluence and consuming, and that takes goods and services to provide. And we know from scientific fact that every major ecosystem in the world is in decline, and we're putting a lot of stress on the planet. And we have this concept of ecological footprint where we can trace how much overcapacity we are. And we're now tracking towards using up 2 planets instead of the 1 planet that we have to maintain life. And if we talk about climate change and energy to start with, which is a big environmental concern, probably the major challenge of our time, we look at the amount of energy we use in the world. It's trillions of kilowatt hours used globally every year. And it contributes to about 70% of the global carbon emissions that we put out. And most of this energy is coming from fossil fuel sources. 81% of the energy we use is from oil, coal, and gas. And about 6% is from nuclear, which means that very little of the energy we use is from renewable sources, which could be labeled as sustainable. We use a lot of materials and energy in the built environment, and most of the energy, 40% of the energy used, is in the built environment. 40% of the carbon emissions is in the built environment. And about 40% of the resources we used are in the infrastructure and buildings of the world, and about 40% of the waste is produced in the built environment and urban environment. So buildings and infrastructure is the 40% sector, 40% of the issue and the challenge we have in terms of sustainability. And in terms of the materials going into the construction and the buildings and roads, steel is a major source. We use trillions of kilograms of steel every year. And it contributes to about 7% of global carbon emissions. Cement is another major construction material going into concrete, and we use trillions of kilograms of cement as well. Equivalent to approximately 500 kilograms of cement every year and concrete is used. It's equivalent to what we eat, what we consume on an annual basis. And we can't really get away from this. We can't miniaturize the infrastructure in the buildings. We still need roads. We need to provide housing, we need to provide sewage system and sanitation to a growing population. We can't really get away from that. We need construction materials. And cement, as a sector of its own, is contributing to about 8% of global carbon emissions. And looking at this, how it's growing. We know population is growing, we know we're using more and more materials to satisfy this, and this trend is going to go on into the future. And we can't really do anything about needing more materials and having a large population. We just have to find a way to do it more sustainable, leaving less of a footprint. And one of the positive things, and I like this slide because it goes back to what actually can happen in industry, what we can achieve. This is the fuel mix going into cement production in Brazil, tracing back to the 1970s. And what you can see is that in the 70s, when oil was abundant and cheap, it was the primary fuel source for producing cement. But then the oil crisis hit, oil became more expensive, and other feedstocks went into producing cement. Markets adjusted and diversified, and at some point they almost used no oil at all. And then market changed again, oil became more abundant and cheap, and they switched back to using more oil, and now they're switching to other sources and considering even using urban waste to produce cement. So we can see that it's not impossible to innovate and adapt and change the way we do things. Technology and production capacity can change and switch quite rapidly, which is really encouraging. So the overall concept I want to talk about today is lifecycle thinking. And at the core of lifecycle thinking is lifecycle assessment, which is a well-established methodology for looking at the environmental aspects of a product or a service. The first company, perhaps counterintuitive, that started using lifecycle assessment was Coca-Cola back in the 1960s. They were asking a question. Well, we have this, the iconic Coca-Cola bottle, the heavy glass bottle, and we go through all lengths to reuse it, to bring it back and refill it and use it for extend its life cycle and extend its use. What if we switch to a different container? What if we use one-way single-use bottles or cans out of PET or aluminium? Would that be better or worse? And they started doing the first, what's now called the life cycle assessment, looking at all the materials going in, the energy fuel uses for manufacturing, for transport, etc. And they came up with an answer that actually reusable and returnable heavy bottles is not always the right answer. Sometimes you need, you can do something like counterintuitive, use a single one-way packaging and not recycle. The second one to look at how to use LCA, it's about finding trade-offs and balances and challenge conventional wisdom. So one example that we often use is the chicken. So we buy organic chicken and we think we're buying organic chicken, it's better for the environment because it uses less chemical fertilizers, herbicides, and it doesn't have any genetically modified organisms, so it's good for the environment, right? But organic chickens can have up to 50% higher carbon footprint than conventional chicken because they live longer, they're happier, they eat more, and they need to be in sheds which needs mechanical ventilation and lighting for a longer period of time. So they use more energy and have a higher carbon footprint. But the chickens are happier, but we clearly have a trade-off here, whether we want to save the climate or whether we want to have happy chickens. So just to illustrate the point that it's not always clear-cut easy what's the best solution. And you really need to look at the whole picture in order to get the answer and the balance right. What we've learned from doing many life cycle assessments over the years is that it does challenge conventional wisdom. Very often you come up with surprising concepts and surprising findings. And a general trend is that about 80% of the impacts, which we'll go into in a second to talk more about, is in your supply chain. It's downstream and upstream from your products, so it's a little bit outside your control. And in a very globalized world, goods and services and materials, they flow across country boundaries, and it's truly a global economy. So it's a challenge to track where everything's coming from and to have the traceability. Now, if we look at infrastructure and take this as an example and see everything that goes into, say, a road, for example, in an urban environment. What we're interested from a life cycle assessment perspective is what's the implications of this road or this piece of infrastructure in terms of human health and ecological quality and resources that we use that are non-renewable and scarce resources. So LCA and life cycle assessment attempts to answer and quantify these questions. And what they do, and what we do with LCA, is that we break it up into a large number of midpoints about specific individual measures of environmental impact that we can measure and trace. And they all relate back to human health, ecological quality, and resources. And then we try to make sense out of what this means and what does this say, and how can we optimize. Life cycle assessment, intuitively you think it's a life cycle, it's circular, it goes from cradle to grave, and there are different ways to do LCA. Not all of them are that comprehensive. You can actually do a life cycle assessment which is cradle to gate. It might be what you're interested in, look at where you get stuff from your manufacturer and how it's manufactured and stop there and try to optimize. Many LCAs, they stop at that point. Others go for construction materials about, well, need to distribute it to site, install it, or look at even how the product is used, how the asset is functioning over life, and what happens to it at the end of life, looking from cradle to grave. But a true LCA should really look at what happens to the materials. Are they recycled and reused into new products? Is the steel kind of recovered and remelted and recycled into new steel? And that would be a cradle-to-cradle analysis. There are different options. At the core of LCA is data. If you imagine everything that goes into this road project, from materials, from fuels, from installation, from energy use, what LCA does, it traces all these elementary flows that goes over the life cycle, and they try to we try to break it up into which of these elements, emissions or resources, relate to what environmental issue. So you might have a long list of chemicals, emissions, and pollutants coming out of the life cycle, but not all of them are affecting the climate. Only a few of them are greenhouse gases, and we identify those, and we quantify them based on their potency. So carbon dioxide would be, methane would be 25 times as bad a greenhouse gas per kilogram as carbon dioxide. So we look at it in equivalence. We look at toxic emissions and resource depletion. We look at a number of different indicators and bring them back to this reference unit in order to measure. From an LCA, you can get all these different metrics in terms of environmental impact, resource use, and wastes and outputs that you then can use to minimize harm and optimize your asset and get the best working overall picture. That's the environmental part of it. There's also the social part of it, and we call this social lifecycle assessment, or SLCA, which is a newer and emerging field. It started with environment and resources, and now social becoming more and more important. One of the driving forces is the recognition that in the world today, we have about over 45 million people that are enslaved, that live in some kind of forced labor conditions, which is huge. And if you look at the global economy and the way we trade goods and services, it's almost naive not to think that the products and the services that we use today somehow has been touched by this issue. There's a great resource in terms of mapping out the risks in your supply chain that doesn't only look at labor rights but look at a broad range of different social issues. It's a database developed in the US. It's a global database. It's called the Social Hotspot database. And it basically allows you to look at your supply chain based on where you spend your money and find out where the major risk is for your organization. And we do projects outside infrastructure in other areas as well. And one of the sectors we work in is in the food sector. And we work with a large supply chain to a major restaurant firm here, a global one. And we said, well, if you look at the food sector and look at the forced labor risk, this is the heat map over the world. And if you look at Australia, it's actually a high-risk country in terms of forced labor. And when we put this to the companies, they didn't believe us, of course. No, in Australia, we don't have any forced labor in the food sector. That's ridiculous. We got the highest standard, etc. And it was a little bit brushed away and said, this is not credible enough. It's not good enough data. And then, whilst we were conducting this study and engaging, ABC came out and said, in fact, this is happening right now. There's a lot of issues around several different food suppliers, not necessarily in their first tier, but second or third or fourth tier down the supply chain. There's stuff going on that the tier one companies don't really have any visibility to, and it's becoming a major issue. Coles is looking at the same thing globally. In the sustainability report recently, they said that they actually stopped trading with some organizations overseas because of their poor social track record and practices. And when we come to sourcing building products, what the social hotspot database can give us is a statistical average view of, for example, looking at the risk, social risk in sourcing timber. In Australia, about 96% of the timber we use is certified and is of really good both environmental and social standard. But if you import from, say, a Southeast Asian country, the risk is higher, not necessarily all products, but the risk is statistically higher. And you really need to dwell in and talk to your direct suppliers and have more transparency in the products you procure. One way to understand your supply chain is to map it out on a global scale. And this is one that we did for a telecommunication business, saying where do you have your retail centers in Australia, where do you procure goods and services? So this is a telecom, so they buy a lot of iPhones and Samsungs from Korea and Apple. And we can say, depending on how much money you spend, what's the proportionate social risk associated with it? And looking at each country, having a different risk profile. And we can then start to map and see, in this instant, forced labor, where's the highest risk, where should you focus your effort? And then look at, if you know anything about your supply, you can kind of eliminate the risk and find out more about what actually goes on, depending on a risk-based approach, risk management approach. So bringing this all together into a triple bottom line framework is where we really want to get to, where we look at not just environmental performance or impact in isolation, not social and economic in its own world, but bring it all together into a coherent framework. So I'll talk you through a quick case study we've done for Transport for New South Wales, where they recently completed the Southwest Rail Link outside Sydney, which they asked us to look at. They have their sustainable design guidelines, which basically rates projects that they do from a bronze to a platinum range. And they asked us, we spent a lot of money trying to get this asset sustainable and get to a high standard. Now, what was the cost to the project? How much money did we spend, and what was the actual return? Can you help us quantify this? So what's the value of a gold rating, basically, was the ultimate question that they wanted to find out. So we developed three scenarios. One where, well, what if you built this Southwest Rail Link or Glenfield to Leppington rail line without any sustainability considerations, doing nothing, just a bare minimum. Compared to what you actually built, where you went halfway. You went to build a gold rating. It wasn't actually platinum, but it was a fair bit of effort put into it, with sourcing green materials, energy efficiency, sensitive water, urban design, etc. And what if you went all the way and went to a platinum-rated building or asset? What difference would that make? And first, we looked at it from a traditional life cycle costing perspective. Look at the cash flow. What's the capex, capital expenditure going in to build this, and what does it cost to run it for 80 years, for 50 years in terms of energy and cleaning and maintenance and operations? Putting that all together, we developed this cash flow model where we said, well, doing nothing would save you money in the construction stage, which you see to the left of this screen. But it would cost you more to run it, slightly more to run it. Doing what you did, you spent a little bit more upfront and you saved money overall compared to doing nothing. But if you've gone to platinum and you've gone all the way, you actually would have had a optimized asset, a better performing asset from a net present value, discounting back cash flows as economists do. So actually from a financial perspective, just in the budget terms, you would have been better off doing a platinum rated building or asset. Now, this was challenged in terms of what's the, there's a lot of uncertainty in this and, it's hard to distinguish. So we added in, that was only the cash flow. What if you factor in the environmental concerns and we only look at the environmental concerns that actually relate to human health? We don't put a price on ecological quality or resource depletion, we only look at human health. And the metric we're going to use is built up from carbon pollution, which we know is less carbon pollution if you went to the platinum rated building asset, which is the scenario 3 here. You would have less particulates going into the atmosphere, less smog formation, and use slightly less water. Now, what if we put that all together into an overall metric called disability adjusted life years and look at how climate change, heat waves, storm surges, smog affecting respiratory illnesses, ozone layer depletion causing cancer, etc., more UV rays, how does that affect the human health, the population health overall? And look at this daily concept and see that there is a degradation over time due to these pressures put out there. And we can put a price on a life year as well. If you take an average person out of the economy and put them in a hospital bed, it's going to cost society in terms of less productivity, but also higher health costs. So we can actually relate this environmental degradation and health effects to a financial price to taxpayers and to the economy overall. And comparing these 3 scenarios, doing nothing, compared to scenario 2, what I actually built, compared to platinum, we can establish that over 50 years, you could have saved 1,000 disability adjusted life years by going all the way on environmental improvement. And then putting that into your financial model, into your economic model, and add another row, which we call externalities, externality cost, and put this health cost, which might not be worn by the transport department, but it would be worn by the economy at large and the Department for Health, etc. So in that case, you get a significantly better business case. You get a 5% lower life cycle cost by optimizing this asset on the triple bottom line. So the business case is clearly there. You save money by doing sustainability. Now, looking at the future, and this is pretty much where industry is at right now, a triple bottom line life cycle assessment, life cycle thinking approach. Being Swedish, growing up in the 70s, I was formed by quite a negative agenda. There was a lot of negativity. There was a Cold War. Limits to Growth was published saying we can't continue the way we are. A lot of waste issues, nuclear, deforestation in the Amazon, etc. It was all very negative. In the 90s, the global community and academics started to build consensus and develop frameworks and mobilize in terms of addressing these issues. A lot of international treaties in the 90s. In the 2000s, we could see these pioneers like Interface Carpets coming out and saying, well, there's actually a business case to being more circular, less waste and product stewardship and cleaner production. And carbon price started to emerge in some economies and some markets where you actually had to pay for this type of pollution, and drove an interest in more and more footprints of products to understand the pollution and the carbon going into, from a life cycle perspective, going into the product. And today we're in an era where we have a lot of transparency. There's a lot of data available. We see business integration, companies working more and more closely with this, and the triple bottom line concept from a life cycle perspective that I just described trying to look at, can we optimize and create social value rather than just minimize risk? Taking this whole of life approach and have the tools and databases available to feed it. And what's coming next is, with more information, people are going to innovate and come up with really clever things to use that. I don't think we can anticipate what's going to happen in the next 5-10 years, but we know that with more information, there's going to be more life cycle-based solution and innovation and supply chain by company A learning more about company B and saying, well, if you're doing this and I'm doing this, let's collaborate for a mutual beneficial outcome. And scaling up. I'll talk about that in a second, the size of the challenge, where we need to get to in terms of carbon mitigation and general environmental improvement. So we're learning more, we get more benchmark, we understand more where hotspots are, so we can make more focused investments in where to improve. And monetizing sustainability, which I just showed in the previous case study, where you actually put a dollar value. It's controversial in some sense, but it really helps in decision making to bring it down into that common denominator, which is dollar or money, that can make sustainability, environmental performance and social performance have a space around the decision making process. And one of the things that come out is we've done hundreds of life cycle assessment of various products in different sectors, and what always comes back is the silver bullet is the circular economy, closing the loop, stop wasting resources and finding repurposes and reuse of products. And today in the construction world, we see a lot of the concrete that we put out at the end of life, it's going to be downcycled into crushed up into road base or similar, less value. It's basically degrading the resource. We see timber, most of it ends up in landfill or is incinerated. Steel, we have a really good circular economy going there. We take back a lot of steel and we remelt it, but that's a highly energy intensive process, and we should really be doing more about reusing steel, marking it up and say, well, in 50 years time, the next generation can see exactly the grade and quality and manufacture of this steel and use it in another project without having to remelt it and waste a lot of energy in between. So the circular economy concept is there too for grabs. It's something that's emerging quickly. And looking at the holistic view, I'll talk about carbon mitigation shortly specifically, but the sustainable development goals is laying out this framework about the world that we want, which issues do we need to work across, and as a country and organization, which ones are the priority for you, where you can make a difference and you should focus. So it's giving a common framework for sustainability for all countries and all organizations. And what we're really excited about is the Science-Based Target Initiative, which is a new initiative that came out of the climate negotiations in Paris last year, where basically the science told us that we're heading towards a disastrous carbon pollution story where we're just going to emit more and more and it's going to have disastrous effects. What we really need to do is to drive down emissions and be carbon neutral by mid-century, by 2050 or 2070, in order to have a planet that we can inhabit in a safe manner. And the challenge is enormous, because I don't think anyone can really envision what a zero carbon economy or organization or product really looks like, genuinely. We need to rethink the way we do things. But it is happening. This carbon budget concept, where we have about 1,000 gigatons left of carbon emissions to put out in the world. Now, over what time scale are we going to spend this carbon budget and put it out as pollution, and which companies, how do we allocate it up between countries and companies? This is where the Science-Based Target Initiative comes from. And it's really taking off in a big way. Even a year in, look at all this, it's a global initiative, and you have almost 200 companies already signed up and doing this, working out their aggressive carbon mitigation strategies. So that's an introduction to life cycle thinking. We could go on, there's a lot to talk about. But another one is the North Australia. I'll hand over to my colleague Ken Lunty, who's responsible for property and infrastructure at Edge Environment. And he's been part of the very exciting project North Australia Link, or North Rapid Transit in Sydney. So he'll talk about the sustainability initiatives and approach to that project.